Hi everybody. Sorry I'm not here today. I'm at a meeting all day at the district office, so I've prepared this lesson that'll help you with lesson 6. So just a couple of quick reminders. You're going to need a pencil. You need a cell phone needs to be in the pocket, and you need a calculator from the back pocket where all the calculators are kept. So please make sure you get all of that. You also obviously need this handout. This handout will guide you through the lesson today. So we are going to be doing lesson 6, which is on equivalent equations. Our agenda today, and you're going to basically be working on it independently. You're going to be doing a math talk, which will involve a which one doesn't belong. You're going to be doing a warm-up, which will involve 2 expressions. You're going to do lesson 6, and you'll be doing an exit ticket as well as part of today's lesson. Our practice for tonight is going to be on lesson 6, and it is on equivalent equations, and it is on blue paper. You'll be able to get this at the end of today's lesson, maybe start it. If you don't want to start this today, you can work on your Delta Math assignment. I want to just make sure that we remember that this is going to be due on Friday. Okay, Friday of this week. Okay, so what are our 3 learning goals? I want you to be able to tell me if 2 expressions are equivalent. I want to make sure that you can do legal moves to transform, or in other words, change an equation. And I want you to be able to understand what it means for an equation to be equivalent. Please remember, this term equivalent means balanced on either side of the equal sign, okay? So it needs to be balanced. Okay, so this very first thing is a which one doesn't belong. You're going to notice that you've got 4 equations right here. And I want you to be able to state or choose one that you feel doesn't belong in this group. And you're going to indicate which one you select, 1, 2, 3, or 4. And I'd like to know the reason why you selected it. So go ahead and pause the video and go ahead and do your which one doesn't belong. So you can see that I chose, for my equation, I chose number 3. And why did I choose equation number 3? Well, I noticed that it was the only equation that started with a 2. So right there. And I could have easily selected maybe another one for a different reason, but that one just kind of came to my visual real quickly. All right, so moving on. We are now going to turn the page, and we are going to do a warm-up. And this warm-up is on 2 expressions. So you're going to do the warm-up, either this one or this one, depending on what your last name begins with. So if your last name begins with letters A through K, then I want you to do this expression. If your last name begins with letter M through Z, I want you to do this equation or expression. So what are you supposed to do? What you're supposed to do is evaluate this expression or this expression using the following values. So what does that mean? That means if I have the value of 5, then what you're supposed to do is substitute 5 in every place I see a variable. Okay? I'm going to substitute 7 in, I'm going to substitute 13 in, and I'm going to substitute -1 in. That's if my last name begins with A through K. If my last name begins with M through Z, I'm going to do the exact same thing. However, I'm going to use this expression. I'm going to put 5 in for n in 2 places, 7 in, 13 in, and negative 1 in. Please remember to pay close attention to order of operations. So go ahead, please use a calculator. Here's some space that you can use to organize your work. And so go ahead and pause the video and do that right now. So you can see that I actually did all the work for both sets of expressions, and what you should have seen is that A got a value of 8, B got a value of 20, C got a value of 80, and D got a value of negative 4. That's if you use this first expression. And if you use the second expression, then you would have gotten that A is equal to 8, B is equal to 20, C is equal to 80, and D is equal to negative 4 as well. So again, if you need to, you can pause the video, double check. You can see all my detailed math work right here. You can pause the video and double check to see where, if you got them right, then that's terrific. If you made some arithmetic errors, you needed to make sure that you followed order of operations. So hopefully you did that warm up and there was no issues doing it. Okay, so moving on to the next page. Basically, it's impossible, so I can figure out all values of n to see if the expressions are the same. So if I go back and I look at the work, and there are more than these values that I can put in for n. I can put in an infinite number of values. And so what that means is I'd have to determine whether they were equivalent or not. So in earlier math classes, if you think back to 6th grade, 7th, or 8th grade year, that you simplified expressions to show that things were equivalent. So what does that mean? So that means that maybe what you did was that you combined, and I'd like you to jot this down, you combined like terms. What else did you do? You added or subtracted. Maybe you multiplied or divided. Or maybe you even use the distributive property. So those are all things that you do in earlier math classes. And you saw problems like this. 3x plus 5 is equivalent to 3x plus 15. And what did we do in this case? Well, in this case, we distributed. Okay, so I want you to, what did you notice about the expressions that you evaluated earlier? So let's take a look. I'm going to go back to my previous page. And I want you to notice that the values were all the same. I got negative 8, I got 20, I got 80, and I got negative 4. So if I look at these, there's certain things that you don't know yet in mathematics that I could have done. And we'll get there eventually. But this could actually be expanded to this. And this, I could have distributed. 8 minus 3, right? 8 minus 3. So there's all sorts of things. 8 minus 3 times 2. Where did I get that? 8. And then I just didn't distribute. I just said 2 times 3. So that's where that came from. So again, there's so many different things that you could do. to make things equivalent, and that's what we're going to do in this lesson. So I want you to take a look at page number 9. And I want you to think about this for a moment, and I want to know, are any of these equations equivalent to one another? And if so, which ones? And can you explain your reasoning or think about why they would be equivalent? So what I always like to do is I'm going to pause the video, and I want you to just think and maybe solve and see what you come up with, or maybe notice things about these equations. Are there moves that can be done to make these equations equivalent? And what are they? So these are just some things that I did. I noticed, in a very traditional sense, if I subtract 6 from both sides, I got that 3a is equal to 9, and then I divided both sides by 3, and I got that a was equal to 3. Okay, and so I did that one, and then I came over here, and I noticed that 3a is equal to 9. Oh, that's the same thing that I got right there. And then I noticed, in fact, I just noticed this, that when I solved for a, I got that a was equal to 3. Well, these are equivalent. Okay, so why are these equivalent? Because I've got the same value of a, that if I substitute a in, it works. So moving on, I'm going to look here, and I'm going to notice that a is equal to 3 here as well, because when I take 3 and add 2, it equals to 5. But now I've got this one over here. How do I solve for a? Well, I can multiply both sides by 3, because I want to know 1/3 of some value equals 1. So what happens? Oh, that's not right. I just saw that I made an error. It's not equals to, it's equal to 1, not 3. So this is a is equal to 3. I made that error. I just noticed my error. So I rewrote the problem wrong. So I'm wondering, 1/3 of some number equals 1. Well, if I take 1/3 of 3, 1/3 cut up into 3 equal, or 3 cut up into 3 equals space is 1, right? So 3 times 1/3 is going to be 1. So I can multiply both sides by 3. What was my move? My move was to multiply both sides by 3. What was my move here? My move here was to subtract 2 from both sides. What was my move up here? My move was to subtract 6 from both sides. And what did I do then? Well, then I had 3 a's equal 9. Well, I could divide both sides by 3 to get A is equal to 3. What did I do right here? I did the same thing. What move did I do? I divided both sides by 3 to get that A was equal to 3. So there are moves that can be done to make equivalent equations. What are they? I could add, I could subtract, I can multiply, and I can divide. I could also distribute. Okay, so I can do all of those types of things to make things equivalent. So now let's turn the page and look at page 10. So now we need to know what's acceptable. What can and what can't we do? So let's take a look here. We've got an equation. And that equation is representing this context. So what is the context? That Noah is buying a pair of jeans and he's using a coupon for 10% off. The total price is $56.70, and included in that price is $2.70 in sales tax. Noah's purchase can be modeled by this equation. So I want you to take a look at this, and I want us to think about, we can't discuss today because you're not working with a partner, but I want you to think about, where do all these values come from our problem up here? So let's take a look. Total price, $56.70, right here. There's my total price. $2.70 is my sales tax right there. I have to add it on. Okay? Noah's purchase, well, what did he purchase? He bought a pair of jeans. Okay, do we know how much money he spent? No. So that's my X. So the only thing that I don't know about is this 10% off. Well, I want you to remember that 10% can be written as 0.10. So, if I have a pair of jeans of X and I take off 10% off the price, so this is the price, this is going to be 10% off of the price. Okay, so we have the price, we take away 10% off the price, we're going to add $2.70 because it's my tax, and the $56.70 is the total price that I pay. So what does the solution to the equation mean in this situation? So what is X going to be? Well, it's going to be the price of my jeans, of Noah's jeans. Okay? And what else? How can we verify that 70 is not a solution? Is not a solution to our equation. But that 60 is. So think about what we did when we found solutions. We need to make sure that on either side of the equation it's balanced. So what I'm going to do is I'm going to substitute in when X is equal to 70 and when X is equal to 60. And let's see what we have. I'm going to go back up to this equation right here, and I'm going to put it in. I'm going to go 70 minus 0.1 times 70 plus 270, and that should equal $56.70. That's what we're saying it's going to be equal to. Okay? I'm also going to do the same thing for 60. I'm going to go 60 minus 0.1 times 60 plus $2.70. And that should also be $56.70. Well, we already know one of them is not going to work because I've been given two values. So what I'm going to do is I'm going to use my calculator, and I'm going to go 0.1 times 70, and I get 7. So I'm going to go 70 minus 7 plus 270. Does that equal 56.70? Well, I can use the math. 70 minus 7 plus 270. Well, that equals 65.70. And that sure as heck does not equal 56.70. So that doesn't work. Okay, so how about over here? Do the same thing. 60 minus, well, this is 6 plus 270 equals 56.70. So I'm going to go ahead. I subtract this. This is 54 plus 270. And I know that these two added together is 56.70. And that is equal to 56.70. So beautiful. 60 is a solution. How did I do it? I verified it by plugging it in, by substituting the value in. Okay, so that's how we determine whether we're true or not true, balanced or not balanced. So now what we're going to do is we're going to look at the same equation again, right here, and we're going to look at some moves that were done to the original equation. And we're going to be given some information that we could use, and we're either going to say what was done, or we're going to interpret it, or we're going to figure out, is it the same solution? How do you know? Okay? And we're going to use 60 each time to make sure that it works. Right? We're going to verify that 60 still works in the solution or in the equation that we transformed. All right, so here we go. Here's the equation, and we're going to look at A. So I've got 100x minus 10x plus 270 equals 5,670. Okay, so right away, I'm going to notice something. I noticed that this number got really big, and this number got big, and that changed, and that changed. So what happened? Well, it looks like everything was multiplied by what? Hopefully you said was multiplied by 100. Okay? So it's interpret why they did it. Well, it's given to us. The price is expressed in cents instead of dollars. Okay? So what they did was they multiplied everything by 100. Well, there's 100 cents in a dollar. That makes sense. Okay? So there are 100 cents for every $1. Okay? So is the solution going to be the same? Let's double check. So I'm going to go 100 times 60 minus 10 times 60, and I'm going to add 270, and does that equal 5,670? Well, 100 times 60 is 600 minus 10 times 60, right, So I corrected myself here. It should be 6,000. So 6,000. So 100 times 60 is 6,000. And 10 times 60 is 600. And if I add 270 back, does that equal 5,670? Well, again, use a calculator. I'm going to go 6,000 minus 600 plus 270. And I don't know about you, I was just kind of thinking about what we did. It should balance, and it does. 5,670 is definitely equal to 5,670. There's my documentation right there. All right, so that's equation A. So what did we do? We multiplied by 100. Didn't change anything because we did 100 to everything. So we expressed everything in terms of cents instead of dollars. All right, now let's go over here. So now it's telling us to do something. It did something. So I started here. X minus 0.1x plus 270 is equal to 5670. What they did was they said, go ahead and subtract $2.70 from both sides of the equation. Okay, so why did you do that? Well, I balanced it. I subtracted. I did a legal move of subtraction. From both sides. I did the same thing. Okay, so let's see what happens. So I got 54. So now it should work, right? If I did the same thing for both sides, then what I should find is that if I plug in 60, it should work. So let's check it out. So 60 minus 0.1 times 60 equals 54. So 60 minus 6. Just 0.1 times 60 is 6. And does that equal 54? Well, 60 minus 6 is 54. And 54 is equal to 54. Check, it works. Okay, so equation B, it worked. Okay, let's turn the page. And now let's look at C. Okay, here's the equation right here. I have x minus 0.1x plus 270 is equal to 5670. I see the 270. I see the 5670. Wait a minute. Oh, look what they did. So what was done? If I have 1x and I take away a tenth of an x, so in other words, they combined like terms. That's what they did, was they combined this term and this term together. Why were they able to do that? Because these both got x's in them, and this is 1x, and you take away a tenth of an x, and what happens? What am I left with? I'm left with 0.9x. So what they said was, if 10% means you're paying 90% of the original price. Oh, that makes sense. So this is 100%, and if I take, this is 100%, and if I take away 10%, what do I get? I get 90%. And 90% can be expressed as 0.9x. Yes. I also combine like terms. So let's double check. Does it work? So I'm going to go back here. I'm going to plug in 60. So I'm going to go 0.9 times 60 plus 270. And does that equal 5670? Well, I'm going to go 0.9 times 60 is 54. There it is. 54 plus 270. Wow, look at that. That equals 5670, which definitely equals 5670. It works. So every single equation that we did worked. So what did we do? So what did we learn today? Well, we could do some moves that can be done to make equations equivalent or keep equations equivalent. So you can balance by adding or subtracting. We distributed. We combined like terms. One more thing I want you to add. We also multiplied. We multiplied on one side to get rid of, and remember we turned dollars into cents. So if you look back at that, that makes complete sense because it was a whole lot easier to deal with, right? I didn't have a whole bunch of decimals to worry about. I was able to kind of just do it on my own. Okay, so what are some moves? Here they are. How can I tell if an equation is equivalent? What do I do? Well, you want to check the solution. You want to make sure that both sides are balanced. All right, so now what do I do? I'm done with the lesson. Now what you need to do is collect an exit ticket right here from the sub. It is a cool down, and I'll read this, right? So I'm going to go ahead and pause the video. I want you to go collect the exit ticket, and then I'll read it, and then you can work on it. Okay, so hopefully you were able to collect an exit ticket, and I want to go ahead and just read it for clarity. So you have a cardboard box. Okay, so here's my box. And it's empty. So that means when it's empty, it weighs 0.6 of a pound, or 0.6 of a pound. What do I fill it with? I'm going to fill it with 15 bags of beans. So that means inside here, I'm going to add 15 bags of beans. And 1 4-pound bag of rice. Okay. The total weight of the box and the contents of the box is 25.6 pounds, 25 6/10 pounds. One way to represent this situation is with this equation. So the very first thing I want you to do is think about, where did the 0.6 come from? What does 15B stand for? And where does the 4 come from? And where does the 25.6 come from? So you need to jot down that based on the problem right here. So again, what does the 0.6 stand for? Where does the 15 come from? What does the B represent? What does the 4 represent? And what does the 25.6 represent? So then it asks you, the very first question is, in this situation, what does the solution to the equation represent? Sorry about the bell. In other words, what will be equal? That's what I want to know. What will be equal? I don't want you to solve it. I want to know, what does B stand for? What does it stand for? What does it represent in the context of this equation? After you do that, what they want you to do is, you're not solving anything. You're going to select all the equations that are equivalent to this one. And I want you to think about moves that were done. And again, think about the moves. Did I distribute? Did I add or subtract? Did I multiply? Did I divide? Did I combine like terms? So I want you to, the way I would do it is I would look at each equation separately, and I would do something to see if I can get it to look like that. Okay, good luck. You'll be fine. When you're done with this, you have two options. You could either ask to work on the homework, which is right here, or what you could do, you can then go into Delta Math and do the Delta Math assignment that's due Friday. Either way, you're going to need to do both. So I would let you choose which one you'd rather do first. And tomorrow for Flex Time, I will be available if you want to come in and we can work on this together. Right? I will see you guys on Friday.